Now screen is visible.
Mm, not it, ma'am. It has started, but yeah. Yeah, yes, ma'am.
Yes. It's a types of memory in computer. So we have discussed up to the RAM. All clear
One
now?
second, ma'am. One second. Sarika, Madhura, can you people see the screen or is it black for you also?
Black only.
Black. Huh.
Why is it so? 1 second.
No, we can see your screen, but I think you haven't shared the PPT.
Okay. PPT is not here, no?
Yeah.
Yes. Now. Now it's here.
Yeah.
Yes, ma'am. Yes.
Yes. Now we have discussed tomorrow up to the RAM. So all clear about RAM. What is RAM? What are the types?
Yes, ma'am.
Yes. Now we will start from the ROM. Okay. Full form of the ROM is read only memory. So we understand from the name is also read only memory. Here we can only read, not write on them. Okay. So it is a non-volatile and is more like a permanent storage for information. So the data we store in the data is stored in this memory is permanent and it is a non-volatile because it is permanent. That why it is called non-volatile. It also stores a bootstrap loader program, as we have discussed. That bootstrap loader program is that the starting program. When we switch on the computer, the program is running behind the screen. That program we called bootstrap loader program to load and start the operating system when computer is turned on. As you must have seen when you open your computer and laptop, the first thing you see is the logo and name of that company because the company that made the computer, that company has programmed it in ROM. Okay, the logo you see in the display unit that programmed it in the that store in the ROM, so that as soon as the computer is open, the brand logo and brand name should be displayed. So there are the three types of the ROM: PROM, EPROM, and EEPROM are some commonly used ROMs. The first one is the PROM. PROM stands from Programmable Read Only Memory. Its full form is Programmable Read Only Memory. So how is it different from the ROM? In ROM, when the manufacturer manufacture this ROM, the program is uh, program is programmed in the ROM at the time of the manufacturing. But in the when the PROM is manufactured, it is empty. It is in empty state. So when programmer, what type of programmer wants to program it, it can be according to his requirement. Programmed can be programmed in this memory according to the programmer requirement. Okay. EPROM. EPROM is the uh, EPROM stands for erasable programmable read only memory. As the names from the name we can understand the program can be erased. In read only memory we can erase the program. So erasing an EPROM, how can we erase the program in the EPROM memory? Through the ultraviolet light. When we expose the ultraviolet light in on the memory, the all data will be removed. Okay, through the ultra. So we have to. The key point is here: ultraviolet light to remove the data in the EPROM. Okay, we can erase the data in the EPROM by the ultraviolet light. Okay, EEPROM. EEPROM is the stands for electrically erasable programmable read-only memory. So in this we also can erase the data, but the mechanism is changed. the EEPROM memory chip has this feature that you can easily erase the data of the EEPROM memory chip and can also program new data easily. So in this, we can erase the data electronically, and we can program new data in it easily. So in the EEPROM, the data is removed at one time, okay? But in this, we can erase the data one by one, okay? One by one. If we want to, suppose we have some program in one page. So if we want to remove half page, okay? So we can remove according to a requirement. The data can be removed according to a requirement, okay? So there is no need to take it out of the device to delete the data of EEPROM chip. So in the EEPROM, we have to remove the chip from the device, but in EEPROM, we don't need to remove the memory chip from the device. Electric power has to be used to erase the data of EEPROM. It takes 4 to 10 milliseconds. Within 10 milliseconds, you can erase the data of the EEPROM. Okay? And you can also erase the data according to you. It means you can erase the data of the entire EEPROM at once, or you can also erase and program the data of the chip part by part. Okay? Understand? You can erase the data at one time, okay? And you can also erase the data according to your requirement, part by part. Got it? The basic difference in between these three devices in PROM, at the manufacturing time, it is empty. After the manufacturing, you can program it. Later, you can program this memory, okay? And then EEPROM is the erasable, but you can erase the data through the ultraviolet light and expose the data at a one time, not part by part. In EEPROM, you can erase the data, electrically erasable data, and within 4 to 10 milliseconds, you can erase the data, and you can erase the data part by part or entire chip according to your requirement, okay?
That's the only major difference, ma'am, in all of this. It's about the
Yes.
erasable part. Okay, okay, ma'am.
Yes, but the ROM means ROM. You can't erase if you want. After 10 days, you need to require the you want to delete. This is not means that. This means that if your requirement is increasing, you want to improve your gaming process. Suppose, take the example. You want your improvement your game instructions. You want to install some instructions according to your gaming. Okay. So after 1 to 10, 2 years or 3 years, you can erase the data. Not randomly, you can say after 1 month or 2 months. This is not, okay?
Okay, ma'am.
Yes. Secondary memories. We have completed the primary memory. Now we started with a secondary memory. Secondary memory is it's also known as secondary storage or auxiliary memory. Is a type of memory that has a large storage capacity. What is the difference between the primary memory and secondary memory? Primary memory is the less storage capacity, but and temporary. But secondary memory is the largest storage capacity and retains data permanently until users erase it. Yes, as we know that when we we are doing some text, we are typing some text on Word. When we save that data will save in the secondary memory, okay? So it is permanent storage. When we want to sometimes you can say that the memory is full, you want to erase some unwanted data, so you can erase according to your requirement, okay? Its non-volatile nature doesn't lose the data, it holds even if the computer shuts down. Yes, as we know that when in primary memory, in RAM, when the power cut, the all data will be lost, okay? So it is slower than primary memory. Yes, primary memory is very fast as compared to the secondary memory. CPU cannot access secondary memory directly. Yes, CPU doesn't talk to the secondary memory. He only access with the primary memory. Okay, it directly assess with the CPU, directly assess with the primary memory only, not assess with the secondary memory. Hence, the data, applications, or instructions stored in it are first transferred to primary memory to make them accessible to the processor. So, when we store the data in the save the data in the secondary memory, it will first transfer to the RAM. Okay. Then, if user want, if suppose I save some data in my desktop. Okay, I want to open. I just give the instruction to the okay. I give the instruction to the computer to I want to open my that data. Okay, the CPU will give the instruction to the RAM or cache memory, cache to the RAM, and then RAM to the secondary memory. Then secondary memory give that data to the RAM, and RAM will give that data to the cache memory, and then it will be executed in front of us. Okay, so hence only primary memory can access the content stored in secondary memory. So secondary memory directly can't access that content. It has to transfer it to the primary memory. Okay. What is more interesting in this type of this type of memory is available inside a computer as an external device. Yes, as we know now, there is no hard disk outside the PC or placed outside the PC or outside the laptop. It is placed in the laptop. It is inbuilt, but we can connect it. We can connect it hard disk, or externally also. So that's why it is called external device. Okay, it is also called external device because we can connect it externally also. So hard disk drives. These are the commonly used secondary memories are hard disk drives, solid state, which is called HDD, SSD, optical disks, SD cards, memory cards, CDs, and floppy disks are common examples of secondary memory. They are also called external memory, backup storage, or mass storage. Why is it called external? Because they are also externally connected. Backup storage because we are that's data we need we stored in that device, and mass storage because we stored it in a large amount. We can store a data in a large amount. Okay. Next is types of secondary memory. Now we will discuss about the types of the secondary memory. First one is hard disk. uh, Hard disk or hard disk drive, both we called it hard disk or hard disk drive or hard drive, is a fixed storage device because it is fixed in the laptop or PC. So that is why it is called fixed storage device, commonly found inside computers, laptops, servers, and other computing devices. It is found in the inside the computer. Inside the computer means to say it is in the motherboard. It is placed in the motherboard. Okay, motherboard is short form of the motherboard is MOBO. So it is an electromechanical data storage device. So data is stored in the electromechanical way. So that why it is called electromechanical data storage device that leverages magnetic storage. The data is stored in the magnetic form to store and retrieve data. This magnetic storage contains several rotating platters placed one after the another. As you see in the diagram, there are some circles. Uh, This one, this one. These circles are called platters that is placed in the hard disk. Okay. So we can differentiate SSD, solid state drive, to the hard disk drive. With this, there are platters present in the hard disk, and they are rotating. They rotate when the data is stored in the hard disk. They are rotate with this arm. This I change the color. Yes, this is the arm. This one is the arm. of the hard disk. So, okay, the data is rotating. When the data is storing in this hard disk, the data is platter rotates, and data is stored. These platters are combined with magnetic heads. There are magnetic heads. There are magnetic heads that are mounted on the actuator arm. This is the arm, as we know. This is as we told you. This is the arm, and there is magnetic head. So we can read and write data to a platter surface. A fixed hard disk is placed into a drive until present on a computer's motherboard. So it is a fixed hard disk. It is called fixed hard disk device because it is placed on the motherboard. Okay, the storage capacities are 256 GB, 500 GB, 1 terabyte, 2 terabyte. So their storage capacity is this much. Okay. So next one is a floppy disk. First, we will discuss the solid state drives between the hard disk drive and solid state drive, because nowadays SSDs are coming in the laptops. Okay, because the storage capacity is much more than the hard disk. Solid state drives are known as the solid state storage devices. Are semiconductor based devices. These are the semiconductor. The hard disk drives are the electromechanical and magnetic storages there. They serve as alternatives for hard disk drives because of their speed. Their speed is much more than the hard disk. SSD do not have moving parts. As like there are platters in the hard disk, there are arm actuators in the hard disk, but there is no present of the SSD. There are present in SSD. There is flash controller and NAND flash memory chips. You have to memorize these words. Flash controller. The SSD is made up of flash controller and NAND flash memory chips. The memory and the name of the memory chip is NAND flash. So there are two primary components contribute to high read-write performance delivery. So one more difference between the solid state drives and hard disk drives, as we can see with the help of the diagram. This is a heavy hard disk drive is heavy, okay, in weight, but SSD is less in weight. Okay, when you see the Apple laptop, when you hold the Apple laptop, they are very light in weight. Now the other laptops are coming also in the SSD, but when you hold it, you can see the difference in between the normal laptop and Apple laptop. They are very light in weight. Because of why they are very light in weight? Because of the there is present SSD. The CPU's the memory device is present in the laptop is SSD. That's why their weight is less, and their speed efficiency is also more than other devices. Okay, this is a basic difference between the SSD and hard disk drive. Floppy disk, and this is obsolete. These disks are obsolete nowadays. We don't use these devices, but we have, because today you will see now the CPU comes without these drives. Nowadays the CPU are coming without these drives, because there is a need of the special drives to enter to place the floppy disk. So there is no nowadays CPU are coming without floppy drives. Also laptop, there is no need of CDs. We can't place the CDs and DVDs in the CD drives or DVD drives. So because there is no drives are coming with the in the laptops, today's laptops. So floppy disk, First one, a floppy disk or floppy diskette is a disk storage device with a thin and flexible magnetic disk. There is also mechanism is used. It is in a square shaped plastic container. The magnetic disk is enclosed in a square shaped plastic container. Okay. Storing data and transferring it between different devices are common uses. We can store and data in floppy disk and transfer the data. Yes, when we store the data, we can place it in, we can use it in other, when we are saving the data in one PC, we can use it in other PC also. Okay. It between different devices are common uses of floppy disks. These floppy disks are offline. We can't use it in online. Okay. One thing you have to remember, floppy disks can't use online. We can't store data in online. Okay. These are used only for offline. However, a computer must have a floppy disk drive to use a floppy disk. Yes, as we know, there is a special need of the floppy disk drives. So for use of the floppy disk. The types of the floppy disks are based on their available sizes. There are different sizes comes in the floppy disk. An 8-inch drive was the first floppy disk design. First floppy disk design was the 8-inch. The size of the first floppy disk drive is the 8-inch, which followed the read-only format. So we can only read the data, can't write on it. Other sizes include 1/4 inches with the storage capacity of 1.2 MB, 3.5. No need to learn this much. Okay. So you have to remember the first floppy disk design, 8-inch. Now these devices are obsolete. Yes, as we know that can't see. Nowadays we don't see these devices. Okay, and replaced by optical disc. These devices are these discs are replaced by the optical discs, CD, DVDs, now Blu-ray disc. Now we will talk about the optical disc. So, understood up to this?
Yes, ma'am.
Yes. Now we will start with optical disc. What is optical disc? Optical disc is an electronic data storage. So we will understand this in hard disk, magnetic storage. In floppy disk, there is also magnetic storage. In optical disk, there is electronic data storage. The data is stored in the electronic form. Okay. The laser light is electromagnetic waves are using to store the data. Okay. To read and write the data in the optical disk is just you have to remember the electronically wave. Okay. Electromagnetic waves. CDs, DVDs, and Blu-ray discs are three common types of optical disc. First one is there are the three CDs in the picture. First one is a CD, second one is a DVD, third one is the Blu-ray disc. Okay. There is a difference of the speed capacity of the storage. Okay. Just there is not little much more difference between these capacity of the storage. This is a basic difference. The CD is a compact disc. Full form of the CD is a compact disc, is an optical storage device made of plastic and round in shape. As we know that its surface has sectors. Surface as sectors means to it's like this is round, and tracks to store and organize data. It organizes data from the disk center and moves outwards. So data stored from the center and moves outward, then storing data outwards. Okay. Towards the edge, forming a spiral circle. This track has sectors that store specific amount of information. A CD has a storage capacity of 700 MB. In a floppy disk, what is the storage capacity? What was the? It can be 1.2 MB or 1.4 MB. 44 MB, okay, maximum storage. But in the CD, there is a 700 MB. We can store the data. It is available in two types. CDR, we can only read the data, or we can also read and write data. Two types of CD comes in the market, read only and read write only. Okay, both. And DVD is the digital versatile disc, or also called digital video disc. It is similar to a CD but has a larger storage capacity, up to 4.7 GB. Now the difference you can see, here is a 700 MB, now here is a 4.7 GB gigabyte. Generally, it is used to store movies, video recordings, and other multimedia files of large size. A DVD is available in two dimensions. There are two sizes comes in the DVD, 12 centimeter and 8 centimeter. Furthermore, as like CD, there is also DVD read and DVD read write are the two available types of the DVD. Okay. Next is a Blu-ray disc. A Blu-ray disc is a high-capacity optical storage medium designed to supersede. It takes the place of the DVD. It can hold data up to 25 GB. Now in DVD, it is 4.7 GB. In CD, 700 MB. Now in a Blu-ray disc, it is 25 GB. Okay. Is primarily used for recording, rewriting. In DVDs and CDs, we can't rewrite. Okay, we can read and write, we can't rewrite. But in Blu-ray disc, we can rewrite and playing back high dimension videos. It leverages the blue violet ray. What type of laser are used in this Blu-ray disc? Why it is called Blu-ray disc? Because blue violet laser is using to store the data. Okay, the major difference between the Blu-ray and DVDs are one is the capacity of the storage, and other one is the blue violet laser is using to store the data. Next is the memory cards, as we used in our smartphones. Now, a memory card is a tiny portable storage. Yes, as we know, we can use in one memory card in more than one smartphones. Okay, portable storage device that stores digital information using flash memory. It is commonly found in handheld devices like cameras. We use memory cards in cameras also, smartphones, game consoles, etc. You can store data of any type, such as videos, audios, files, documents, PDFs, etc. We can all type of data we can store in the memory cards. It is available in different storage capacity. Now, what's the capacity of the memory cards? 8 GB, 16 GB, 32 GB, 64 GB, 128 GB. Okay, up to 128 GB. The memory card capacity is this much. Next one is magnetic tapes that also have obsolete. A magnetic tape is a secondary storage device, consists of a long, narrow plastic and polyester film of magnetic coating. As we see, somebody see the cassettes that play in the audio player. Like they are like rolls, black magnetic tapes like present in the small cassettes for listen the music, listen the songs.
Olden days
Yes, madam.
cassettes you are saying, ma'am.
Yes.
Olden days cassettes you are asking.
Yes, small cassettes, yeah, used in the audio players. Yes. This is also the type of the magnetic tapes, and also the movies comes in the big black color magnetic tapes. When we play the like marriage videos, we record the marriage videos also. There's some extra what they say, VCRs, we call VCRs to play that magnetic tapes.
Now
Yes,
out
madam.
of
Yes,
date,
madam.
ma'am. Now out of date, actually.
Yes, they are obsolete. They are obsolete, but these are the secondary storage. They store the data. Okay, because there are in this storage, the capacity of these magnetic tapes are much more than the other devices. Okay, but now these are obsolete because of their Data backup and archival storage are potential uses of, yes. They are used for the store the data only. Okay. Now, next one is the cache memory. Now, come to the next last one, memory is cache memory. This small size memory, chip based memory in computer lies between the main memory and CPU. Yes, as I told you now, this is a memory hierarchy. I will in next I will teach you about the memory hierarchy. This is first one is a CPU, then registers, then cache memory, then RAM memory, then secondary storage devices. Okay. So cache memory lies between the main memory and CPU. It is very close to the chip of the CPU. CPU directly access to the primary memories. Okay. And cache memory is also the comes under the before the primary memory. CPU, cache memory, then primary memory. Okay. So it is very close to the CPU. The aim of this type of computer memory is to enhance the performance of the CPU. All memories, the aim of all memories are to enhance the utilization of the CPU, the performance, to increase the performance of the CPU. So these memories are using. So why so much memories are using in the computer? To enhance the performance of the CPU. So the utilization of the CPU is much more efficient then. Okay. So it is a high performance and temporary type of memory. It is also a temporary type of memory. So we can't store the data permanently in it. That reduces. The main purpose of this memory is to reduce the access time of the data from the main memory. So when the data comes from the secondary memory to main memory to cache memory, so the access time will be decreased. Access time decreased for the CPU. Okay. Every instruction and data that is often used by the CPU is stored within cache memory. So every instruction and data, it's understand like this. When we are typing some text, the storage, you understand, I just typing one page. I'm just typing one page, not more than that. I'm just typing one paragraph. That paragraph will be stored in the cache memory. Okay. Because it's you can understand like that. It's space. Its memory space is less than the main memory. When I want to more than one frames, like I'm using more than one frames now, like I'm using my PPT also, I'm using your Meet. I'm also working on the Google Meet. I'm using also my PPT. I'm using two frames at a one time. Okay. So that's why I'm working on the RAM. But when I working very small instructions, I'm working on very small work. So that time only cache memory will be accessed. Only cache memory will be used for small instructions, for small data. Then as compared to the main memory, then we will use the CPU will access the cache memory. Okay. Cache memory is of three types. There are three levels of the cache memory: level 1, level 2, level 3. So why there are three levels? Because of their speed. Level 1 is much faster than the level 2, and level 2 is much faster than the level 3, and level 3 much faster than the main memory. Main memory is slower than the level 3. Okay. So we will understand from the memory hierarchy also. So there are, first one is the CPU registers. Okay. There are CPU registers that is present in the CPU. Registers, please note that point. Registers and level 1, maybe sometimes level 2 also present in the CPU. They are inbuilt, manufactured in the CPU. Registers level 1 and level 2. And now level 3, they are placed outside of the CPU. but very near to the CPU, and RAM is a little bit away from the CPU, but near to the level 3. Okay, got it? Now, then RAM, then hard disk, then other devices. Okay, so RAM, they are connected with the buses. I will tell you about buses also. These memories are connected with buses. There are some address bus, control bus. All buses are different functions. So these memories are connected with buses. So first we will understand about CPU. In CPU, there are present registers and cache memory. And level 3 cache memory, sometimes they are present outside the CPU. Then RAM memory, then hard disk. Okay, and then other offline storage means they are present outside the PC. Okay, like tapes, like CD drives, these are present outside the CPU. We are externally entering the magnetic tapes or CD drives, floppy disks. So these are offline storage. So we understand the speed. When those memories are close to the CPU, their speed is much more than the other devices. As registers speed is much than the cache, then cache speed is much more than the RAM, then RAM speed is much more than the hard disk. Okay. Okay. Yes. Now cost. As the speed is increasing, the cost is also increasing. Registers cost is very expensive. Cache is less than registers, and RAM is less than cache, and hard disks are less than RAM. Okay, and tape drives are least expensive. Okay, but storage capacity is increasing. Registers are very much small, very much small. Cache memories are bigger than registers. Then RAM are bigger than cache memory. Then hard disks are bigger than the RAM. And then offline storage are bigger than the hard disk. Okay, got it?
Yes, ma'am.
Yes. So you have to understand. CPU directly access to the registers. Then he didn't get registers are, you can understand, registers are only used for very small information, like you can understand address of that portion, address of that text. For example, I presenting this is my PPT. This PPT have some address, so registers are only for finding out that address, storing that address. Okay, then registers, then cache memory. Cache memory is also for small information. Okay, that if CPU will talk to the registers, then he will not get the address information from that. Suppose, for example, I am typing some documents, I am typing some text in the laptop. Okay, I saved it. When I want to find, I want to open again, I want to open that again. First, what will happen? I'm just typing. I will show you in a slide.
So we try to retrieve what we have saved, ma'am.
Yes, yes,
That
yes,
is
yes. One second, I will tell you. Yes. For example, this is CPU. I will try it. This is CPU. This is registers. This is cache memory. Sorry. Try it. Yes, this is main memory, RAM, and this is hard disk. Okay. Yes. Now I give the instruction to the CPU. Okay. CPU will talk to the registers. He will not find the he will not find that information in the register. Then he will talk to the cache memory. Then cache memory, he didn't find the that, he will talk to the main memory. Okay. Then main memory, he will not find. He will find. Obviously, he will find the data in the main memory. Okay. Then main memory will talk to the hard disk. Okay. For example, as we see in the you see the in the laptop, the local C There is local C drive. You see? Local C and local D drives. There are. Anybody see? There are, when you click on the local C drive, they open desktop, downloads, documents. There is some sequence. I will show you. Are you able to see my screen now? Try to show you. This will not present. 1 second. Yes. Are you able to see my screen?
Yes, ma'am.
Yes. Yes. This is a local C drive, local disk D drive.
No, no,
Is
that screen we are not seeing, ma'am. What you have drawn, that I am able to see.
Oh,
Yeah, only
I
the
have to show my all screen. Share me. 1 second. Drive screen. Yes. Now, is it visible?
Yes, ma'am.
ये local C drive, local D drive. Is it visible?
yes, ma'am. Yes, ma'am.
Yes. These devices are the, what are these devices? These are the secondary storage. The data is stored in the secondary storage. When I click on it, this will open. Desktop, downloads, documents. This icon will be opened. Okay. Desktop. When I click on it, the all data of the my desktop will be opened. Okay. So these all data is stored in the secondary storage. Okay. When I will try to open it in, when I will try to open it in, it will open in the RAM. Okay. Where it will be open? It will be open in the RAM. So storage device, understand from this point, secondary storage is talking to the RAM. It will not directly talk to the CPU. So the data is stored in the RAM, secondary storage. It will come in the RAM. Then RAM, then who is giving the instruction to the RAM? CPU is giving the instruction to the RAM. So my data is in the, for example, I have my data is 1 second. So my registers are maximum. Registers can store maximum 64 bytes. Registers can store maximum data, maximum information of the 64 bytes. 64 bytes, not more than that. This is the capacity of the registers. And then cache. And that cache capacity is the maximum 512 bytes. Okay. 512 bytes. When my data, when my information, when my document is more than the 512 bytes, the cache will not open. Cache will not access. So that the data will open in the my file will be open in the RAM. Okay. Got it?
Yes, ma'am.
Yes. Now the scan from this. One second. Yes. So CPU will give instruction. So once one more thing you have to memorize. So this is the local C drive. This is a secondary storage but the data is stored in some address. The data is stored in some address. Who create this data? Who create this address? CPU create the address. CPU create the address, but it's stored in the secondary memory. Why? Because CPU don't know about secondary memory. He just generate the address and give to the memories, give to the registers, and then registers give to the cache memory. Cache memory give the main memory, and main memory gives the address to the storage device. and that address is called the logical address. Please note down this. What address is gives to the secondary memory? That is the logical address, and CPU generates a logical address. But when my file is opening in the main memory, when my file is opening in the main memory, the address will become physical address. Please note down. The file is executing. That file is executing. That address will become physical address. But when the data is CPU generates only logical address. When the question come in the what type of address generates CPU? CPU generates logical address, and that address goes to the secondary memory, but through the register to cache to memory, these steps. Okay. But when the program is executing in front of our screen, that address is called physical address, because this is present in front of our eyes. That's why we call it physical address. Got it? Please note down this point. This is there anybody any doubt? Please you can ask.
No, ma'am.
Understood now?
Yes, ma'am.
Yes. So logical where one thing more, where logical address is saved, that is called, sorry, that is called global database. So secondary device is called global database. Okay, global database. And where the program is executing, that is called local database, because there is a local data. That is where data is 3 points are regarding the secondary memory. Physical address, okay, where his data is permanently saved, that is called physical address. And where the data is permanently saved, that place is called global database. And that data is called global data, that is permanently saved. So 3 points: physical address, global database, where data is placed, and that data is called global data. And where the program is executing, that address is called physical address. And where the data is placed, suppose main memory, the data is executing in the main memory, that place is called local database. And that data is called local data. When the program is executing in front of us, that data is called local data, and that address is called physical address, and that place is called local database. So please note down these points. Okay, got it? Now we
Ma'am,
finish.
once again explain, ma'am. Local database or global database?
Okay, where the data is permanently stored, that place is called global database. Okay, where the data is executing presently, where the data is executing, understood this way, executing, so that place is called local database, and that data is called local data. Okay, got it?
Yes, ma'am.
Yes. Now we finish here. Is anybody want to ask some questions? They can ask. Yes. So please ask if anybody wants to ask. Okay.
Ma'am, I don't want to ask anything, but I
Okay.
just want to check if I understood right. So When the CPU sends the information to registers and from there cache, then main memory, and then to second memory is the logical address. And if the
One thing.
data is processing in front of us, it is a physical address.
Good question. Good question. I just explain one thing more. Is yes, understood. Now CPU generates only logical address. Okay. One thing remember, when the CPU generates only logical address, when CPU gives gives a command to the memories to execute that program. If I want to open my some program, okay, I want to open my presentation. CPU, I give the command to the, I text some I want to open that, I give the instruction to the computer, okay? I give the instruction, okay? The CPU will give the command to the registers, and then again, okay? Then what will open? Local drive, hard, the data, because I know my data is stored in the hard disk, okay? But CPU don't know. As we understand now, we are understanding these concepts. So when I open this address, hard disk will give the information, the data to the main memory, okay? Hard disk will give the, this is the logical address, okay? This is a logical address. When the data will go to the main memory, it will become logical address. Okay, this is so confusing, but you have to memorize. You have to understand this line. When the data is going to the main memory, it will become logical address for the main memory, because now data is present in the main memory. Where the data is present, that becomes a logical address. Now data is going to the cache memory. It will become logical address for the cache. Okay, now it will become for the, now it is going to the registers. Now it will become to the logical address for the.
Ma'am, can we get this again in the next class?
Yes. Sure.
So one thing, ma'am, if I'm getting it right or wrong, do you mean to say logical address is basically reverse of the
Yes.
whatever?
So one thing, there is a logical address. Okay, when the data is transferred, one thing, it will become physical address, because the program is executing now. This is become for a physical address. When data is going to the cache, okay, the data is executing now here, it will become physical address. Where data is executing, where that become physical address. Other main memory, for main memory, it will become logical address. I will understand tomorrow, okay? There's so much hodgepodge.
Ma'am,
Yeah.
which one is giving that is logical address and which one is receiving that is physical address?
Yes.
Okay,
Yes.
thank you.
Yes.
Now,
Now,
this was good.
okay.
Thanks.
Yes. Understood now?
Yes, ma'am.
Maybe tomorrow you can brush it up
Yes.
one more time.
Yes.
Thank you, ma'am.
Okay. Now let's wind up the class. Yes. Back next straight. Sorry, I have to stop the recording.